Hello guys and welcome to this session of Node.js. Today we will be diving into a little deeper into some of the core concepts of the JavaScript language and which are helpful in Node.js. So before moving on, let's try and understand again, why do we need to learn Node.js? Well, first of all, if you look at this Google Trends page, so I've searched for Node.js. Looking at the trend of Node.js since 2004, but Node.js, it was created around 2009 2010, so before that, there's not much activity for that. But after 2010, I would say, if you can see, there's a constant growing trend. And if you compare it with other languages, let's say like PHP, or let's say Java. So for PHP and Java, you see a kind of a constant downward trend, and PHP is almost 25, 28 years old now. Java is almost 30 years old now. Node is hardly 10 years old. So that is why comparatively you see Node has, over here if you see, the graph is much lower for Node, but Node is much younger technology compared to PHP and Java. But for others, if you see, there is a downward trend since last 15 years. Another point, JavaScript today is everywhere. Okay, here is a tweet by a guy called Jason Mays. He's a developer at Google, okay, and in the TensorFlow team. And he tweeted a few days ago saying that JavaScript is now also in space. It was used for kind of a dashboard in one of the SpaceX rockets that were launched by SpaceX. So that's another thing. So here is one of the main reasons why you should learn Node.js. So this is the benchmarks game, uh, hosted on the Debian website. Debian, a Linux operating system used a lot on Linux servers. And here you have a comparison of the performance of different languages. If you don't know what the computer language benchmarks game is, here is a Wikipedia page explaining that it's basically a set of algorithms, and what you do is you run those algorithms in different languages and you compare the performance. So we have it over here. You don't see Node.js, but you do see Java. Sorry, you do see JavaScript. And so if you can compare JavaScript with languages like C++, Dart, Java. So versus Java, if you see, so Java is a compiled language. Node.js is not a compiled language, but still Node.js is a winner in two categories, and it's pretty close in many of the categories compared to Java. If you compare Java with, let's say, PHP, sorry, JavaScript with PHP, so here you can see Node.js, PHP is a winner in two categories, but in rest of the other categories, Node.js is a clear winner when you compare it. PHP is also a scripted language, same is with Node.js. And you can see Node.js in some of the categories, it's way better than PHP in performance in benchmarks. Same with Python. If you compare JavaScript with Python, so Python is a winner in two categories, but in many others, well, all of the others, Node.js is a clear winner in different kinds of benchmarks. So Node.js is much better in terms of performance. And last but not the least, Node.js is used by many top companies these days. One of the examples is Netflix. You know, everybody knows Netflix around the world today, and almost I would say 20 to 25% of the internet traffic today in the world is Netflix. So Netflix uses that on their server. Even companies like PayPal use Node.js, and there are many more. So these are the main reasons why you should be learning Node.js if you haven't learned till now. Before we move on, a word about OdinSchool. So OdinSchool is a technology upskilling platform. We help you continuously acquire new skills. So stay skilled and stay ahead. Uh, Talking about me, guys, my name is Vijay Makhija. I started my career around 2010. Over the past 8 years, I've been a freelance web developer and a trainer. And over these years, I've got a chance to work on many technologies. I started my career mainly with PHP based technologies. I got a chance to work on CodeIgniter, WordPress, even Magento. But over the last few years, as you also saw the Node.js trends, I moved to more JavaScript based technologies in front end and back end. In the back end, I've got a chance to work on Node.js and Express. In the front end, mostly I've worked on React, but I've also worked on other front end technologies like Vue.js. And needless to say, I've used jQuery, Bootstrap, those kind of things. Apart from websites and web applications, I've also tried my hands on Chrome extensions and chatbots. So let's start. So the concepts that we will be trying to understand today will be the basics. They will also help you if you're doing any kind of some of them will be helpful no matter what kind of programming you're doing, and some of them are like more core concepts of Node.js. So we'll be understanding call stacks, callbacks, asynchronous programming, promises, single threaded event loop, which is like the main core concept of why Node.js is Node.js. And so call stack. And as you can see, I've highlighted the word stack. So this is a stack of plates. You can imagine a stack of books or a stack of chairs. So what is so special about a stack? Stack is, if you ask any computer, stack is one of them. What's the specialty of stack? Stack is a LIFO. Stack follows the LIFO, the last in first out principle. What does that mean? So let's say these are books. You keep book one on your table, and then you put book two on that, book three, book four, book five, and then book six. And then you tell someone to, like, just tell them to, hey, take a book from that stack of books. Obviously they'll take the book from the top. Well, you can say, like, in the using the analogy of books, somebody can pull a book from the middle. But for better imagination, try and imagine a stack of chairs. Okay, and then obviously the person would take the chair on the top. So the chair on the top was the chair that went last in to that stack. So you kept the last chair on the stack, and that's the one that comes out first. That's why it's LIFO, LIFO. Stack is a data structure that's used for functions in all languages. Wherever there are functions, uh, the stack data structure is used, no matter it's Java or C Sharp or any language or even C. So this is how actually functions work. So you can imagine we have, let's say, four functions. Main, a function called main, a function called f1, f2, and then f3. Now imagine a code where the function main calls f1, and then f1 inside its function definition calls f2, and then f2 calls f3. Now you might know the concept of returning. So a function can return a value or might not return a value. But even in case when a function is not returning any value, still the function does return. So when the function does its work and it's done doing its work, it returns the it returns back the control to the function that originally called it. So main calls f1, f1 calls f2, f2 calls f3. F3 once does its work, it's done doing its work, the control returns back to f2. Okay, so that's what we call as the function returns. So this is how the functions will be called, and then once F3 does its work, it returns the control to F2. So F3 gets popped out of the stack. Okay, so the terminologies to be used are push and pop. Okay, so push is when something comes into the stack, pop is when something goes out of the stack. Okay, and so the last one that came into the stack will come out first. That's why LIFO, last in first out. So F3 work is done, it pops. Now on the stack, the top one remaining is F2. F2 finishes its work, it pops out of the stack, and then F1 and then main. So this is how basically a function stack works, or a call stack works. Okay, no matter which language it is, this is how functions work in the form of a stack. So after call stack, another word that you will hear a lot when you're doing any kind of programming in any JavaScript library, framework, Node.js, front end, back end, anywhere, will be callbacks. So if you have worked on front end, you might have used a code like this. So in vanilla JavaScript, you would create a button and then create a object of the button like document.getElement by ID. Imagine this is the ID of the button, and attach a event listener to it, a click event listener, and then pass in a function. So this function that you see over here will be called whenever the button is clicked. So this is based on a user event. Whenever user clicks on it, the function gets called. So we call this a callback function. As simple as that. This is a simpler but a jQuery example. Imagine this is the object, the $btn is the object for the same button. This is the same thing but in jQuery. So there is a high chance you might have seen something like this. Okay, the same thing, on the click of this button, this function will get called, and this function is called a callback function. So but these are user events. Okay, in Node.js, callbacks are also used in case of not only just user events, but you can say something like system events. For example, I have three examples over here: file reading, query, network request. We don't know how long would it take to read a file. We know it will be fast, super fast, but still it would might be some milliseconds or microseconds. Same goes for a query. Queries can take from some microseconds to maybe a few seconds. Okay, or even more than that in some cases if you have a huge database. Network request, again, it depends on various factors. We don't know how long it will take. So this is how Node.js uses the concept of callbacks. In the previous lecture we also understood the non-blocking. Node.js, you will never find a function that directly uh, does some hard hard disk IO. Okay, for example, reading a file, but there is no function in Node.js that actually reads a file. Node.js will only call a API below it that would actually do that work for Node.js, and while we get a response from that underlying API, Node.js, these callback function will be called only when we get a response from the underlying API that hey, the file is ready now, we have the data, here is the data of the file that we just read. Same goes for query, and same goes for network request. So these are mainly three examples of how callback is used in Node.js. Um, Now, because of this non-blocking IO, and then this the way we use callbacks, uh, we know JavaScript as a language is asynchronous, and thus Node.js is as well. But then, what does it mean by being asynchronous or synchronous? Okay, so the first example over here we see is, you can imagine we have three tasks to do. One is the orange task, another is this brown or black task, and then we have an orange task. sorry, yellow, black, and orange. Let's keep it that way: yellow, black, and orange. So if, let's say, Node.js or any other language that we are working on, let's say the language is synchronous in nature. Synchronous meaning we only do one thing at a time. Okay. So, and also imagine this white portion in all of these tasks as a wait time. Let's say the first task is to run a query, second task is to read a file, third task is a network request. In all three cases, we have to wait. Okay. Uh, so let's say first task, running a query, the function does something, this orange function does something, runs the query, and then we wait. Okay, imagine this is roughly 2-3 seconds, and then we finish the task. Once this is over, only then we can start the next task, which is reading a file. Again, the function does something, initiates reading a file, and then we wait, let's say a second almost, and then we get the data from the file, the function finishes, and then last task, let's say we have to do a network request. We initiate the network request and then we wait, and let's say this is like 4 seconds. So 3, 1, and 4. Okay, so 3 plus 1, 4, 4 plus 4, 8 seconds of wait time, and only then we finish all 3 tasks. This is how something would happen in a language or a platform which is synchronous in nature, where things happen only one by one. Now look at this example. Let's say Node.js, being asynchronous, does the same thing. How things would happen in this. So first we would run a query. As soon as the wait time starts, okay, so while Node.js is waiting, it doesn't mean that Node.js won't do anything. Node.js would continue to the next task, that is reading a file. As soon as reading the file gets initiated and the wait time starts, Node.js doesn't wait. It initiates the third task, that is the network request. Okay, and as you can see, so by this time we have all 3 tasks initiated. Okay, all 3 of them are being processed somewhere um, below the Node.js level in the operating system. And then once, so as you can see, the first task that would be finished would be reading the file, because the wait time is hardly a second. Then we would get the response from that. As soon as the 3 seconds are over, we would get the response of the query, and then later part of that function can be finished, and then almost after 4 seconds we would have the network request finished as well. So you can imagine like this. So over here the total time took was much less than this. It's clearly visible by this diagram or this figure. Okay, so this is the main difference between synchronous and asynchronous programming. Now we understood callbacks, how they work, but there's one more thing called promises, which provides us a better syntax and a better structure to our code, and also helps us in doing some things that uh, in callback we would might land into some kind of trouble while debugging our code. So imagine this scenario, okay, where we have these 3 things to do: reading a file, running a query, doing a network request. We know Node being asynchronous would run it in this fashion over here. But let's say the result of the reading a file is needed to run the query, and the result of the query is needed to run the network request. So in that case, we would have to do things this way. Although Node JavaScript being asynchronous, but still there is a requirement, there is a need that we need to do things in a synchronous way. Only when the first task is finished, we do the second task. Only when the second task is finished, we do the third task. In that scenario, what would happen to your code? Okay, it's In programming culture, it's called callback hell. So that is why I named the function as callback hell. So imagine I run a query. This is the callback function for that. So this function gets called only when the query is finished running. When the file is read, this function gets called. Only then I can make a network request, callback function for network request. So when the network request is is finished, done doing its thing, this function gets file. We log to a file that so and so tasks were done. This was done at so and so time, and then we do so we have a callback, a callback inside that, a callback inside that. This 4 callbacks. Okay, and this becomes complicated when you are trying to debug things, when things don't work, or C is hardly a few lines, but then once you add logic to it, there will be if else conditions, try catch blocks, error handling, exception handling, and then clearly this will become a callback hell, the way the function is named. So what is the solution? So there is also a website dedicated to this term called callback hell. Okay, where they discuss in detail about what is a callback hell, what is a callback, what needs to be done. So they've given best practices of what you can do, what you can't. Like instead of just defining your function where it like so the run query takes in an argument which is a function. Instead of defining the function over here, you can keep the function um, out of this and then just put the function name over here. Okay, so at least your code would look shallow. uh, Let me open up. Okay, so this is the um, console of Chrome browser. You can open it by Control Shift J or F12. Okay, and this is also basically the V8, the same engine that powers Node.js. So if you're doing basic stuff like you just want to test a function or a callback, which is a pure function, not something like reading a query, running a query, reading a file, or making a network request, not things like that. But if it's just JavaScript, you can try it out in this as well. So keeping your code shallow, what they basically means is if you, let's say, have so let's say this function run query takes in an argument, and the argument is a function which is a callback that run query would call. Instead of doing something like this, what they are saying is do something like this. Okay, as simple as that. Just pass in the function reference instead of actually defining the function there itself. That's one thing. Another is keep your code modular, which is like a common best practice for no matter what platform or language you are using. Again, another best practice, handle every single error. So try to do that. That'll again come with testing. As you test your code more and more, you'll be able to try to catch all the exceptions, and also handle all the errors that might arise. But then there is one more thing, which is promises. Okay, promises. Now what is a promise? So now we understand the problem. Okay, the callback hell, callback within callback within callback. So promise is a kind of syntax or kind of a feature in JavaScript that helps us in coming out of this problem. So I named the function as promise to the rescue. So imagine a code like this where I run a query. Okay, dot then only then read a file. Once the file reading is finished, only then do the network request, and only then you log to a file. Okay, so the syntax is much more readable. Okay, it's much more understandable. And these read file, get request, log to file, these all are functions which you can imagine are declared somewhere above this function. So this is basically what a promise code looks like, but let's try and understand it better, uh, how it works, what it is. Okay, so I'm opening the Mozilla developer site for and open the promises page. So what is basically a promise? Uh, so a promise is a proxy for a value not necessarily known. When the promise is created, it allows you to associate handlers with an asynchronous action's eventual success value or failure. So dot then and then this function. So this is basically a handler. If the run query task was a success, this dot then would be called, and if this task was a success, this then would be called. Okay, this is not a complete promise code. There is even a catch over here for handling in case there was an error. So we'll take a look at that as well. So there are basically, so this basically shows what a promise is. So let's say we have a promise. Initially the promise is in a pending state. It can be either pending, fulfilled, or rejected. Okay, as soon as the promise is created, it's in the pending state. If it is fulfilled, the callback inside the then is called. If it's rejected, there are two options inside the then. You can have another function over here, comma, you can put another function over here, or instead you can keep a catch in the end. Okay, uh, and they can again, both of them can again return a promise which you can again form a chain. Okay, so over here you can see there is a promise chain. So let's try it out. Okay, so creating a promise is pretty easy. New pro, okay, sorry, let me give it a function. I'm sorry. I passed in a function inside this new promise code. Okay, as you can see, the promise is in pending state. Okay, now this promise will never get fulfilled or get rejected because there's no code inside that function. So how to do that? Again, as you can see, I'm doing in the browser console. I'll also show you the an example via node. So what happened? I just ran this code and I got this promised and it says fulfilled. Okay, so where did the pending status go? I got the promise status as fulfilled, promise value as okay, which I passed in, but then again this is not clear. So what to do? Well, there is this function called set timeout. Okay, in JavaScript. Okay, set timeout will help us in creating kind of dummy code. So set timeout basically waits for n number of seconds or milliseconds before doing something. So what I'll do is First, I'll show you what set timeout is. Set timeout takes in two arguments. One is a callback function, and the second argument would be milliseconds. So 1000 milliseconds is 1 second. So two arguments. One is the callback function, okay, and the second is the milliseconds. So if I run this, okay, after slight delay, you see the set timeout callback was called. If I increase that delay, say 2, okay, same I can do again, let's say 5, and as you can see, so set timeout is basically this. So it does something after some number of seconds. So we'll use this to understand promises. So we have a promise. So what we will do is, okay, so see, already we have a callback within a callback. So so in this promise callback, we have set timeout, and this set timeout will run this resolve, okay, after 2 seconds. So now let's see. Oh, as you can see, the status is okay. The reason why something didn't pop up is resolve just changes the status of the promise. But to see something, I'll have to do a console log. Console log also works in Node. So the same code will also work in Node. Okay, so now we have a promise working. Okay, similarly we can do resolve and reject. So now coming to the so similarly I can do reject. Okay, so obviously in your real world code there would be some condition, something going on, if this, resolve, else, reject, something like that. uh, okay, so again, if it's a reject, it's actually a exception that needs to be caught, and that's why you have the catch function for that. So now let's write it in the way that I showed you, like this. So imagine I write a function. Now this function has to return a promise. Okay, this function has to return a promise, and so this is a function that has to run a query, right? So okay, so as soon as this callback function of the promise is called, Promise passes in two objects for resolve and reject, which we can use to resolve or reject the promise based on our code. Okay, and so our function is to run a query, and imagine this set timeout is running a query takes 1.5 seconds to run the query, and then we say okay, the query was a success, and so we do a resolve. You can pass in whatever message you want in the resolve and in the reject. It's for a developer, it's for you to decide what messages you want to pass within functions. Okay, so now what you can do is, we know this function would return a promise. Okay, if I run this, returns a promise. Okay, but now we see the output, but that's console log. Okay, we didn't actually handle the success of this. So to do that, we can add a then. Okay, whenever you're doing a console log, and if you want to um, don't do things like this. Okay, don't do concatenation, just add a comma and then add n number of variables. Console log can take n number of arguments, just keep on adding comma, don't concat. That's an extra operation, and if data is not a string, if it's object or some other data type, concatenation would not give you the exact result. So when I run this, you see the then callback query successful. So this data that you see over here is actually what we pass from the resolve. So you can pass anything that you want from the resolve. You get inside the then callback, inside this then callback, so whichever variable you name over here, and then the we do our thing. So now again, I can't write so much code over here, it's gets confusing. So I'll do one thing. I'll open Visual Studio Code, and we'll run the same thing over here using Node. I'll go to terminal, new terminal. Okay, okay, so I'll just copy this function, paste it over here. Okay, or I can open another terminal if there's not too much space over here. Okay, okay, so moving on. So we were at this. The funny thing is, promises help us in escaping the callback hell, but then internally promises do use callbacks themselves. uh, and then you have a catch. we'll call it exception. Okay, so the function inside the catch would be called, in case we call reject over here. So if I comment this out and if I say reject, okay, let me run this. Simply node, so just type node index.js, okay, catch callback rejected. Okay, by the way, this tool is called Hyper. So if you don't want to, so if you're using Windows and if you don't want to use the plain simple CMD, you have a couple of options. That is CMDER. Okay, that's a nice tool if you want to use. Resembles Linux or Unix based terminal. And then you have Hyper. Also there is Git bash. If you're using Git, there would be a Git bash command line tool also. You can use these are good tools if you want, if you're bored of CMD. Okay, so I have Hyper installed. Okay, so now to make it work like a real world example, what I will do is, so in in JavaScript we also have, excuse me, we also have JavaScript functions for mathematics. So we have a lot of functions. As you can see, you will find them easily in MDN, the Mozilla Developer Network site, all of their definitions. There is this function called random, math.random. It would give you a random number between 0 and 1, so with decimal values. So what I'll do is I'll write a simple code, math.random. So if math.random is greater than 0.5, I'll resolve it. Else reject. So now I don't know. Okay, the number would be random. A random number, I don't know, greater than 0.5 or less than 0.5. So you never know. Okay, it would be random. So now we don't know whether the promise would resolve or reject. Okay, so now let's run this again. Okay, successful. Again successful. Let's see if we get a, okay, rejected. So okay, it's fine, it's working. We might get a success or a reject. Again we got a reject, one more reject. Okay, so this is working. Okay, now one of the best practices for in the callback hell that we saw was to keep your code shallow. Now here you can see we have this callback of the promise 1 and then 2. We have 2 already and 1 if else. Okay, so it's better if we have functions defined. You can even put a function inside a function, no problem in that. Okay, so I can just cut, I would say promise function, put it over here. Okay, I can okay, so this is one of the best practices that were given in the callback hell website that we saw. Okay, so try to write your code like this. Okay, so this is basically shallow code, so also better to understand. So if let's run this. Okay, okay, so resolve again, we will have to pass in the resolve reject over here. So a solution for that would be Again, a solution for that would be a function within a function. So to keep things simple, I would just, yeah. So you can declare a function then and there, but still give it a name. Again, even that's a good practice. That will help you in debugging. So let's run this now. Okay, it's running. Okay, so resolve and reject, to be able to use them within this in a function, you can do that, but that they have to be um, in it, like what we did before. The function was declared over here, so the scope outside it is run query. So any variable that we have in run query, so let's say x can be used in this function and this function, but over here we have resolve and reject, but then we have to pass it to this function if you do it like this. Okay, and actually a way to do that would be something like this. Okay, but then again we are anyways creating another function for that. So uh, so again, as a developer, it should be your call. You should be able to decide what's better for you. Okay. Okay. So we have this. So this is, we have one promise running. We don't know whether this would be successful or not. Okay. Now let's add one more task to this. Okay. So we have run query. Let's say I create one more, like network request. Okay. Some network request. Okay. Uh, we can keep the same function name, but for our so to keep things simpler, I'll name it a little different, promise function 2. Okay, also over here. So this network request, let's say it takes a little longer. Okay, uh, but we want network request to run only uh, if this one is successful. So we can copy this and then just paste it over here. Okay, so we can write it like this, no problem. Okay, just make sure you don't have anything in between this area. Okay, after this bracket closes and this dot, so you can do that. So we will keep a catch in the end. Okay, so I'll say network request rejected, network request successful. Our logic is same. If math.random greater than 0.5. Okay, so once we run the query, if that is successful, we will run the network request, and if that is successful, we will need another 10. So both tasks done, then callback. Okay, so let's run this. So then callback, network request successful, both tasks done. We don't have any console log message. So the this then so the data for the resolve that happened for run query, we will get over here. Okay, because this function goes in the first then, and you can even use this data if you want. Okay, you can pass in this data, okay, along with, if you want, it's up to you. Okay, and in case there is a reject, this catch callback should be called. So but this was a successful task, so let's try again. Catch callback. So but again, now in this case we don't know which one got rejected. Okay, so okay, rejected, meaning this one. Okay, you should write better messages. Okay, so even if the first one, even if run query is rejected, then we don't go to any of the subsequent thens, we directly go to the catch. So let's say even there are 10 sequence of callback chains, one after the other, anyone uh, is rejected, directly we go to the last catch. Okay, or the other way of doing this would be, in every then you write another function. Okay, in every then, and then you don't need a catch block. So then I'll comment this out. I'll name it catch callback 1 and catch callback 2. Okay, so run, so first function that returns the promise, and then we have a then. If it's a success, we call this one, uh, and a catch callback 1 and a catch callback 2. Let's see how this one goes. Okay, sorry, I forgot to define this ex. Okay, okay, so catch callback 1, so query was rejected, and then callback undefined, and both tests done. Okay, so the query got rejected. Okay, and after that this then was called, both test done. Okay, so we catch the the rejection then and there, and then we can also move forward if we want. So there are both ways of doing this. Okay, so this is basically what promises do. Okay, we can, I could even add a third function over here, uh, doing the same thing, okay, with same similar logic. So moving on, so we understood what promises do, basically. So now trying to understand one more but very important concept in Node.js is single thread event loop. Okay, so imagine this, we have three functions: main, f1, f2. Okay, main calls f1 and then f2, both are called instantly. Function 1 has a set timeout, and then that set timeout waits for a second. Function 2 waits for 500 milliseconds, half a second. So by now you might have understood that, okay, even though we call f1 first and then f2, we know f2 would finish first and only then f1. So let's try it out. Let's see. So I'll write function f1, 2, set timeout, copy this, f1, f1, and then function main calling f1 and then f2. Okay, so let's run this. Let's run this in the terminal. Okay, so sorry, not. Oh, I didn't call the function main. Sorry for that. I had to call the function mains. Okay, just defining the functions doesn't do anything. I have to run the main function. So F2 callback first and then F1 callback. Let's try that again. Same again, same again. Okay. So if we call F1 first and then F2, we know. So we know this one gets finished in half a second, and then this. But how does these things work? This waiting time. Okay. Set timeout. Okay. Like we are setting the time manually, but yeah, we in real world we wouldn't know. But then it's crucial to understand how these things work, and the concept to understand for that is single threaded event loop. So what is that? So this is a basic diagram of single threaded event loop. First two words underlined: single thread. JavaScript is a single threaded language. Okay, JavaScript is a single threaded language. To understand it simply, you can only have one call stack. Okay, you might know Java is a. Okay, we have a question in our chat. Raghavendra asking, how would the breaking of code into functions help me as a developer? So, Raghavendra, it's called the modularization of code. Okay, breaking your code into smaller modules helps a lot. Now, how does it help? First of all, if you have, so there is this concept called spaghetti code. If you haven't heard of it, Google it. Spaghetti code. So now what is spaghetti code? Imagine your college days, first year of your college, you're learning C, you write the void main, and then you write all your logic, all your code in just one file, in just one function main. Okay, also you have a lot of if else going on. Also in C, as far if you remember, you have this go to statements which you don't have in these newer modern languages. But spaghetti code, as the name suggests, spaghetti code is basically code which is not properly structured, it is not modularized. You have a lot of logic, lot of things going on in just one function or in just one file, which in the future, let's say you're trying to debug, or some developer after you is trying to debug, he goes through hell, or she. Okay, now to make your code better, or to make your life as a developer, as a programmer better, there are a lot of things, a lot of concepts like these that if you go and read, and if you go and try and understand, you would know what are the best practices. Also, big companies like Google, Microsoft, Facebook, even internally they have their own best practices for code. You can Google them, like for example, Google best practices for code, something like this. Okay, voila, the first link, second link, These are all GitHub pages for Google. So okay, the fourth one is Google best Google's engineering best practices, something like that. Okay, so you can go through pages like these. Different companies have their own different ways of doing things. Let me see if I can find. So there's one thing in my mind I wanted to show regarding this, which I had read long back. Okay, so let me show you that. For example, it was many years ago that I had read some Google best practices, some Google blog, which obviously I can't find right now, which basically said, let's say you have a variable, okay, and let's say you have a code like this, okay, and then you do something over here. Variable x, and then you have some code, and then you have if x equal 10, which is if x is equal to 10, do something. I specifically remember what Google said was, don't do this, do it like this. Because now this is the same, x equals 10 or 10 equals x, but how does it help? Let's say as a developer you make a mistake like this. This will not result into an error. Okay, this will not result into an error. The value 10 would be assigned to x, and then the if block would be executed. However, if you followed that best practice of Google, and if you wrote the code like this, the value first and then the variable, and in case you forgot the equal and you just had one equal, that would be an error. JavaScript doesn't compile, but then there are other languages which are compiled languages. So at compilation, you would land into an error. So this is like one example of a best practice that I had read long back, but then it made sense to me. So keeping your code modular helps you in debugging, because in let's say you're trying to debug something. Let's say, can I show something over here? Let me see. Okay, let me see if this works. Okay, let me try. Right click, break on subtree modifications. Okay, so what I'm doing right now is I'm trying to debug. Okay, to show you again, I'll close this, I'll start this again. So I have this page open of Mozilla Developer, and let's imagine this is my website. Okay, I'm working on this, imagine that, and I try to debug something. Where is that button? Make promise button. It was supposed to be here, isn't it? Where is that button? uh, Let me refresh again. Okay, here it is now. So I'll open inspect. So I have the uh, Google Developer Tools open. So I know when I click on make promise, so this, the result of that is being entered into this div with id equal to log. I'll do a right click, break on subtree modification. So anytime anything inside this div changes, the execution of JavaScript will pause. Okay, this is what basically it does. Okay, so I've added this debug point. I'll click on the button. As you can see, paused in debugger. So now in the debugger I can see where the code has paused, and I can see the call stack over here. Over here right now it only shows one function. I can move step by step. I can go to the other functions, and now as you can see in the call stack, as I've moved forward using this button, I know test promise has called a anonymous function. If I double click on that, I can land over here. Now this is the anonymous function. The syntax is the arrow function. Okay, and it's a promise. If I had named this function in the code, I would see the name of the code over here. Sorry, name of the function over here. Okay, so that's one benefit of naming the function if you had named it. But again, in JavaScript and Node.js, people use anonymous functions all the time. Okay, but if you can do it, it's better for you. So you can see the call stack over here. Now breaking your code into, first of all, it's pretty obvious that if you have let's say n number of things to do, if you can actually write n number of functions for that, so one function doing only one thing. So imagine mathematics. Imagine if you are writing a mathematics library. So one function for add, one function for subtract, one function for divide, things like that. Okay, think in those terms. Also, there are other principles in programming. For example, the dry principle, which is don't repeat yourself. Okay, that's one principle for programming, which again, if you're into any kind of programming, try to follow this principle. If you see any block of your code or any part of your code which you have even written like twice and in two different places in your code, you can write a function for that and then use it at both places. Okay, so once you get into programming, you write code, and once you see that the code base is such huge and many files, it would be pretty obvious for you that writing modular code is in your best interest, because then it would be easy for you to maintain, easy for you to debug. I mean, I promise you it would happen to you at least once in your life. Even if you're a greatest programmer, you write some code and you visit it, you see it again after 6 months or a year, you would say to yourself, dude, what the hell were you thinking while writing this code? Why did I do this? Things like that. But I mean, I also write this in some code best practices some years back, that if you have written a function and if you have to scroll your code window to see the whole function, it's not a function. You need to break that. Okay, so the function should be something as small as you can see in front of you without scrolling. Okay, anything bigger than that is not a function. So yeah, you can read n number of articles or blogs on that, but only when you put it into practice you would understand how things help you. I hope I was able to convince you. I did not give a theoretical proper definition. I tried to show you things which I've experienced, which I've seen, which I've learned. Okay, so coming back, single threaded event loop. So JavaScript has single thread, which means you only have one call stack. Many of you might know that Java is a multi-threaded language, meaning if you have 4 threads, you can have 4 call stacks, 4 different call stacks. Okay, but JavaScript only has a single thread, so it has only one call stack. So no matter how many functions you have, you only have one call stack to run it. But if you remember, I've told earlier that many of the things in Node.js doesn't do it directly. Okay, so Node.js is basically V8, the JavaScript engine used by WebKit or Chrome. Upon that, there are a set of libraries that help you things like that help Node do things like make network request, create HTTP server, read file, write file, this that, run a query. So on top of that, there are these libraries, and on top of that, you write your code. So let's say you're running a query in a MySQL database or a MongoDB. Node, the functions which are in this call stack of the node code you're writing, they won't directly access the hard drive and do the IO, but instead they would pass that task to the underlying APIs. Okay, and those APIs are the place where this waiting for the set timeout happens, the actual network request happens, the actual file reader, and that's not under our control. That's all written by Ryan Dahl and other of his friends or colleagues who maintain the node.js, and they wrote all the APIs for all that. And I think they are basically in C++, but they run under the hood. We can't see that. So this is how basically it works. So we have a call stack. So let's say main f1 f2. We know f1 f2 both had a set timeout. Okay, and set timeout had a callbacks. So now imagine this: we have a call stack, and we have another queue, not a stack but a queue for the callbacks. So this is how it runs. So we called the main function, main called f1 and f2. So we have all this in call stack. Now f1 f2 both of them had a set timeout. So that set timeout task goes over here in this underlying API or the underlying layer. So what does set timeout do? It only has to wait for n number of milliseconds and then call the callbacks. So let's say first the 500 milliseconds is up. The callback for that set timeout comes into the callback queue, and then you have the another set timer running that goes off like an alarm, and then the callback function for that comes into the queue. Now as soon as they come into the queue then waits for this call stack to finish. In Node.js or in JavaScript, any function that has to run, it will run only when it's in the call stack. Otherwise it won't run. As simple as that. Call stack is the place where functions run. Put it in your head. Okay, so now the 500 milliseconds and the 1000 millisecond, that time is up. We have the functions in the callback queue waiting. Okay, and waiting for what? The call stack to get empty. When will the call stack get empty? Well, f2. Now let me show you. Yes, so if you remember, I had discussed asynchronous and synchronous programming. Node.js is asynchronous, okay, because it's basically JavaScript. So for f2, as soon as it calls set timeout, it returns. Okay, f1, as soon as it calls set timeout, it returns, because then it doesn't have anything else to do. Okay, it won't wait for set timeout to finish. Node.js doesn't do that. Okay, so it returns. So by the time is up and the functions are in the callback queue, this call stack is actually empty. And then the function, so once the call stack is empty, and these functions come into the call stack, okay, and then they get called. This is basically how single threaded event loop works. Okay, and this keeps on going continuously. Callback queue, once it has a function, it keeps on checking the call stack if the call stack is empty. As soon as the call stack is empty, whatever functions we have in the callback queue, they get pushed to the call stack, and then they get executed one by one. Okay, no matter which callbacks these are, they can be a callback for the promise, for the query, for the set timeout, file reading, network request, anything. Okay, so this is basically how the single threaded event loop works. Single threaded because we have one call stack. Single threaded language can only have one call stack, and yeah, this is the event loop that keeps checking the callback queue and the call stack. Call stack, once it is empty, if the callback queue has functions, it will push to the call stack. This is a YouTube video. If you search in YouTube what the heck is event loop anyway, or if you just search what is event loop, I'm sure this would be first video that comes as a result, viewed almost 1.4 million times. This is by far the best video that you can watch. Okay, it's not by the creator of Node.js, but it's by some other guy again, but at JS conference, the same conference where almost a decade ago Ryan Dell had given his original presentation for Node.js. So this guy very nicely explains what the event loop is, basically what I just explained. Okay, so watch this video if you can. You should actually. So to give you a simple recap, basically we understood what CallSTACK is. Stack is a simple data structure. LIFO, if you remember, last in first out. Imagine a stack of chairs. If there's a stack of 10 chairs, you can only take one chair at a time. Out of it, you would take the top chair. So the chair that went in last into that stack would come out the first one. So that's LIFO. So any language you take, the functions, the way they are called, the way they are executed is using the call stack, in the way of call stack. Then we understood callbacks. Okay, so that's what asynchronous programming language like JavaScript uses to be asynchronous. So callbacks basically in front end, you can say they are used when you have a event like a button click, but in Node they are used for many other purposes like running a query, reading, writing a file, a network request, anything that we don't know how long it would take, but then once it is done, we need to do something. Okay, we need to do something once a file is read or written, once the query has executed, things like that. So for that we use callback, which is basically a function which we pass into another function as an argument. Okay, and that's basically what is asynchronous programming. Okay, then we understood promises, why we need promises to save ourselves from the callback hell, and also the syntax is a little prettier than callback. Okay, in fact, one more thing, just like promises, okay, you have MDN. Okay, so there's another way of writing promises which is called async await. Okay, basically it is, I would say, syntactic sugar for promise. So this feature came, I think, since ES7. Okay, so you can have asynchronous functions, and then if those functions have promises, you can use the await keyword. So basically your code would look like synchronous one, but then under the hood it's actually asynchronous. So yeah, this is like a simple example for that. So let's say you have promises which might resolve or reject, and they're asynchronous, and we need to wait for this promise to execute, and only then you want to run the next promise. You can put in an await keyword before that. Okay, but to be able to do that, the function that they are in, you have to type in the async keyword before that function. So just to tell the interpreter that, oh, hey, this function is actually asynchronous, but then inside over here we have promises for which you'll have to wait. Okay, so this will basically just run like the way we did earlier, like we have a promise, a function returning a promise, and then we do dot then, and only then run the next promise. But here this is a better syntax for doing the same thing, just using the keywords async and await. This is supported since the ES7 syntax. Okay, so this is also one more thing, but yeah, you should try the basic syntax of promises first, only then jump to newer syntaxes, because then this would teach you how to actually structure your code, how things are working. I would suggest start from the bottom, start learn the basics, the fundamentals properly, do all that, face the issues, then move to the better feature, and then you'll be able to appreciate it even more. So call stacks, callbacks, promises. So we get a gist of asynchronous programming, what it is. And one of the most important features is single threaded event loop, where we understood that JavaScript is a single threaded language, so it has one call stack, but then using the event loop, it manages the callbacks which come from the underlying APIs. So that's how we understood how it works. And don't forget to watch that YouTube video I just showed you. And so yeah, and the way the okay and the way this work happens, so functions that come into the callback queue from the underlying APIs, that's mainly where the event driven programming of Node.js comes in. Okay, so in Node.js, we have the event emitter object. Okay, node event emitter. So if you come to the node API website, say node website for the API page, so we have this page for the event emitter. And so this is basically what is used internally for many of the node APIs um, to trigger the callbacks. Okay, basically to trigger the callbacks, so handling the events. Okay, so for example, let's say node library for handling, for writing MySQL queries, imagine. So they would have to give you an API wherein you can run a query, and once the query finishes execution, a function gets called. So to do that, they will have to use something like this, the event emitter object, wherein they run the query, and then when the uh, callback function needs to be called, an event is emitted. Okay, a better example for event would be what we would be seeing in the coming lectures as well, is the server example. So nodejs.dev. So this is the new website of Node.js. You go to learn. In the introduction, so we have an example of Node.js application over here, the most common hello world example, where they create a Node.js server. So let me open this in full screen. What happened? Let me open that again. Let it load first, then I'll click on edit full screen. Nope, some issue. Anyways, I'll zoom it over here and then show you. So we import this HTTP module which is built into Node. We declare the host name, which is localhost or 127.0.0.1. Port, we're taking from the environment variable, but you can imagine something like 8080 over here. And using http.createServer function, we create a HTTP server using Node. It is as simple as that, http.createServer. Inside we pass in a callback function. This is the arrow function syntax. Okay, basically you remove the function keyword, add an arrow, and that's it. You have a arrow function. And then you just send a response saying hello world. So to start the server, this code is required. Server.listen, port name is passed over here, then the host name, and then the function. This function gets called once when the server starts, so server is running. But every time a user opens this page, the localhost page, this callback gets called. Okay, so internally, so this is again, in a way, it is a user event because a user did open the browser and request for this URL along with this port. So imagine 127.0.0.1 colon 8080, and this callback gets called. Uh, so internally, this is how like they use the events. So the HTTP module inside the create server, they um, emit an event saying that hey, a user has requested this URL, and the function gets called, and then this function gives a response back, which then you see in the browser. So that's basically how it works. You can give it a try very quick. Okay, instead of, I don't have the environment variable set for the port number, I'll just say 8080. Okay, as simple as that. And I'll node server.js. So we have server running at 127.80.80, and once I call this, or once I open that address, I see the hello world. So internally, in a way, when um, a request is received, and then all the whatever backend processing needs to be done is done, then this function gets called. Okay, and then we get the response because of this line. Okay, these are things for later, we'll try and understand in the coming lectures. So basically, now you get a gist of Node.js, the call stack, callback, uh, asynchronous programming, how the single threaded event loop works, and you get an idea of event driven programming. Just a simple idea. We didn't go much deep into that. We will keep it for later. So, in the end, I would say thank you. Don't forget to like and subscribe to our channel. I hope you enjoyed this session, and I hope to see you in the next session. Thank you very much.